Okay, good morning. So welcome back to the second lesson where we are going to revise ions and ionic bonding. But before we get on to that, let's finish the first lesson's questions first. Now, the first lesson's questions can be found in our Chemistry OneNote under Content Library, under Consult and Booster, as you see on the screen. The first lesson is entitled JH2, and during the first lesson, we actually went through what are atoms, what are ions, right? So let's do a very, very quick revision of what we did last lesson. Firstly, we went through what is present inside an atom. So we have protons, electrons, and neutrons, which differ according to their relative charge and relative masses. Okay? Then we also went on to speak about how we can use the periodic table to get the proton number. And from the proton number, we know that for an atom, the number of electrons is equals to the number of protons. So in an atom, the number of electrons and the number of protons should be equal and the same. And this is because atoms are electrically neutral. So the number of positive protons must be equal to the number of negative electrons, such that the atom has no overall charge. So atoms do not have charge. Atoms are not positive or negative, okay? And this is because the number of electrons is equal to the number of protons. And we went on to say that from the number of electrons, we can begin to arrange them into shells, and that's what we call electronic configuration. So electronic configuration refers to how electrons are arranged in shells. So we use potassium as an example. Potassium has 19 electrons. So not all 19 can fit into the first shell because there are rules here. There are rules that dictate how many electrons each shell can contain. So the first shell contains a maximum of 2 electrons only. The second shell contains a maximum of 8 electrons. The third shell usually contains a maximum of 8 electrons as well. So potassium, 19 electrons, so it's 2, 8, 8, 1. All right. Now, so based on 2881, we can say that potassium atoms have 1 valence electron. And from the number of valence electron, which is 1 valence electron, we can tell that it's in group 1 of the periodic table. Okay, so the number of valence electrons will determine the group, whereas the period is determined by the number of shells. So potassium is from period 4 because it has 4 shells of electrons. First shell, second shell, third shell, and finally, fourth shell. Okay, how do we know there are 4 shells? Because it's 2881. That means 4 shells contain electrons. Now, this is not a stable atom. It's going to be reactive. How do we know that? We know that it's going to be reactive because it doesn't have a fully filled outermost electron shell. It only has 1 valence electron, therefore it will lose 1 valence electron to form the potassium ion. Okay, so we went through ions last lesson. Potassium forms its ion by losing 1 valence electron, and when you lose 1 valence electron, you become a positive ion. So positive ions are formed when the metals lose valence electrons. Lose electron means there should be less electrons than protons. Therefore, the charge is positive, K+. Now, metals lose valence electrons. Non-metals, on the other hand, will gain valence electrons. So, for example, chlorine. Chlorine is a non-metal in group 7. We know it's in group 7 because it's 287. It has 7 valence electrons. So it's group 7. If it's group 7, 7 valence electrons, it gains 1 valence electron, becomes 288. When you gain electrons, you become a negative ion. All right. So this is what we did last lesson. We spoke about atoms, we spoke about ions. All right. So with this, we can now do some of these questions that you see in JH1. So last lesson, we went through question 1 already. So if you had missed the previous lesson, please watch the video for the previous lesson to see how we will do question 1. All right, there's a certain problem solving technique. All right, now let's go to question 2 now. Okay, So I hope you can find this in your OneNote. It's under Consult and Booster, JH1. Okay, still on the first lesson. Now, whenever you are faced with something like in question 2, what do? Right? Firstly, you need to know where to start. You are given loads of data. You are given contained details of 7 different particles. They just say particles. They don't say whether it's atoms or ions. So it could be a mixture of atoms and ions. So some of them are atoms, some of them are ions. So you need to go and figure out slowly. So where do we always begin? Whenever you are given data about number of protons, electrons, you will start with the proton. Okay, always begin with the proton number, because the proton number tells you what is the name of the element. By going to the periodic table and matching the proton numbers, we can work out what the element is. And that is crucial. You should do that first. So we are now going to do that. So I hope those in the Zoom meeting, you have a periodic table handy next to you. All right. If you have a periodic table next to you that you can refer to, can you please give me a thumbs up so that I know you are ready to start? Okay, how about the other 2 of you? Do you have a periodic table ready? So once you have the periodic table ready, give me a thumbs up so that I know you are ready. Okay. So once you have the periodic table, can we now find out, based on the number of protons, what K to Q are? Which element are they? All right, let's take about 3 minutes to do that. Okay. Okay, so if we have used the proton numbers correctly, remembering that proton number is the smaller number of the 2 numbers that you see for every element. The smaller number is the proton number. So if we have identified the proton numbers correctly, then we would find the elements' names to be as such. Okay, helium, boron, nitrogen, neon, sodium, and chlorine. Okay, so this already gives you a head start because you realize that many of these questions can simply be answered just based on the name of the element. Take, for example, part B. They want you to say which particle is placed in group 0 of the periodic table. So even if you didn't really know, okay, you based on the element's name, you can already work it out. Group 0 are the noble gases. If we refer to your periodic table, they are found on the most right-hand side of the periodic table. So based on the names of the particles so far, which particle is found in group 0? There is actually more than one answer, right? So if you look at the names of the elements which you have identified based on the proton numbers, you realize that helium is in group 0. So on the right-hand side of the periodic table, in group 0, neon is also in group 0. It's also a noble gas. Therefore, there are 2 answers. K, which is helium, and O, which is neon. All right. So just based on the names of the elements, you can easily work part B out. Next, let's look at part D. It will form an ionic compound with chlorine. This means that it cannot be chlorine itself. Chlorine doesn't form an ionic compound with chlorine, right? Chlorine is a non-metal. So to form an ionic compound, it means you need a metal. So you have to choose a metal from your list, because only metals can react with non-metals to form ionic compounds. So based on the list that you have written out so far, which one is a metal? You have to think, is nitrogen a metal? Is boron a metal? And so on. You know that metals are found on the left-hand side of the periodic table, right? So once you know that metals are on the left and you are looking for a metal here, the metal that you are looking for in this list is, of course, sodium. Okay, sodium is a typical metal. Okay, so sodium symbol in this case, sodium is particle P in this case. Sodium reacts with chlorine to form sodium chloride. Sodium chloride is an ionic compound because it contains a metal and a non-metal. All right, so we have solved part D as well. Now, another question that we can solve just based on the name of the element is actually part F. Which two particles are isotopes of the same element? Okay, so in case we have forgotten, what are isotopes? Isotopes are atoms of the same element with the same number of protons. So the proton number is the same. They are the same elements, but different number of neutrons. So the only difference is their number of neutrons. So just based on this sentence, you can clearly see there are two particles which are the same element. And that's, of course, the two boron atoms. That's L and M. Okay, so really, just based on the names of the elements, we have solved 3 out of 6 parts. Okay, so remember the first step when doing such a question is always to look at the number of protons and identify the element. The next step after the number of protons is we need to move on to the number of electrons. Okay, so you are also given the number of electrons in this table, so we should make use of this next, right? How are we going to make use of the number of electrons? The number of electrons will tell us whether it's an atom or ion. How? The number of electrons will let us know if it's an atom, if it's equal to the number of protons. So for example, particle K has 2 electrons and 2 protons. So particle K is an atom. Particle K is a helium atom because the number of electrons and the number of protons is the same. Next, particle L is a boron atom because the number of electrons and the number of protons is the same. M is also an atom, N is also an atom, O is also an atom. They are all atoms because the number of electrons and the number of protons is the same. P is also an atom, right? 11 electrons, 11 protons. So the only one that is perhaps a bit peculiar is Q. Q has 1 more electron. Q has 18 electrons, but it only has 17 protons, which means that it has 1 more electron. This means that it cannot simply be an atom. It is in fact an ion. We said before, if there's more electrons, means you gain electrons. Electrons are negative, so this is Cl minus. All right. And so with that, I think you can quite easily work out which is the ion with a negative charge. So let's do part E. Which particle is an ion with a single negative charge? That means must be a minus charge. That's Q. All right. So based on this alone, you are quite easily able to work out, right? Now, let's finish the rest of the other 2 parts. I think it's quite straightforward. Which one has 5 neutrons? Now, neutrons, remember, you must take the nucleon number minus the proton number. The big number minus the small number. Okay, which one has 5 neutrons? Okay, you see which one, you minus away, you get 5. I think the answer is L. 10 minus 5 equals to 5. Okay, and finally, last one, part C, which one has an electronic structure of 281? 281, 2 plus 8 plus 1 equals 11. electrons. 11 electrons corresponds to sodium, which is P. Okay, so this is briefly how you will do such a question. And this is actually the O-level question already. Okay, but this is also valid for the N levels. So it's good to know how to do this, right? Okay, so for those in the Zoom meeting, once you finish copying down, okay, these things, can you please give me a thumbs up so I know you're ready to move on? Okay, so hopefully you realize that there's a certain step-wise method to doing such a question, all right? So please don't forget these steps because they are really, really helpful. Okay, if you look at question 3, which is next, you will use the exact same steps. Use the number of protons to find what is the name of the element first. If you don't even do that, then you won't get it right. Similarly, question 4 is also the same. Use the number of protons to find the name of the element first. Right? Now, I will not be going through questions 3, 4, and 5 for JH1. I will just be putting up the answers. So please do check your answers on OneNote later. But please try it on your own first, because nothing beats trying it on your own. You will have to do this on your own in the prelims, in the N level as well. So this is a good test to see whether you can do it on your own. All right. Now you can actually write out the answers in your personal folder. So take, for example, you can go to your personal folder with your names. You can find this document under homework. All right, the same document is under homework, and you are able to edit it if you are in your personal folders. All right, so please go to the homework folder and finish up JH1. All right, this will help you prepare for your prelims and your N levels better. Now let's go on to JH2, which you read, okay? It's about ions and ionic bonding. Now, you are also able to find this in your personal OneNote folder with your name under homework. So under homework, you will also see JH2. So can you please open up this document so that you have it by your side as we start this lesson proper, all right? Okay, so this document can be found in your homework folder under your personal OneNote folder for the chemistry class notebook. All right, so if you cannot find it, please message me so that I can help you with it. Okay, so last lesson, we already spoke about ions. So it's not new, right? We know that atoms will lose valence electrons or gain valence electrons to form ions. So today, we are going to do a revision of that. Okay, so let's start with something simple, sodium. Sodium has 11 electrons. If it's 11 electrons, it means it'll be 2, 8, 1. Right? We just saw that. So 2, 8, 1. 2, 8, 1. Right? This is the sodium atom, where there are 11 electrons and 11 protons. The number of electrons and protons is the same. Okay, no charge. Now, the atom of sodium clearly is not going to be very stable because it has 1 valence electron. So we have already seen this. It will lose 1 valence electron. So when it loses 1 valence electron, it becomes 2, 8. So we are also able to draw that 2, 8. However, we know that it has lost electrons. If it has lost electrons, it cannot simply be uncharged. When you lose electron, you lose the negativity in your atom. That means your ion is now positively charged. So this is the Na plus ion. Okay, so this is how sodium loses 1 valence electron to form the Na plus ion. Now, besides being able to draw the ion and the atom, all right, you need to be able to draw each of them, the atom and the ion. So in the exam, right, we will often ask you, draw the electronic structure of a sodium atom. So atom is this one on the left. So you just draw the one on the left if we ask you for the atom. But if we ask you for the ion, draw the electronic structure of a sodium ion. Draw the one on the right. You should not be drawing both. The question will stipulate clearly what to draw. So you must know which one to draw. Atom is the one on the left, before losing electrons. Ion is the one on the right, after it has lost one electron, after it has gained this positive charge. Okay, so please be clear which one to draw. Next, besides learning how to draw, you need to learn how to describe. Okay, so you must be able to describe in words how and why sodium forms ions. So the sodium atom has electronic configuration 2, 8, 1. So the atom has 11 electrons, so it's 2, 8, 1. Hence, it loses one valence electron. It's important to say valence. You will only lose that one electron in the valence or outer electron shell. So it loses one valence electron to form Na plus ion. Okay, which has a fully filled outermost electron shell. Now, you notice that I've used two colors because if this is a 2-mark question, how are the marks allocated? First, you need to tell me that it loses one valence electron to form Na plus ion. That's 1 mark. The second mark is why. Why must it lose one? It loses one valence electron so that it can achieve a fully filled outermost electron shell. All right. Can? Now, this fully filled outermost electron shell is an important term. It also has other ways of expressing it. This can also be known as stable noble gas electronic configuration. Now, why do we call it noble gas electronic configuration? Because it has 8 electrons in the outermost shell, therefore it's fully filled outermost shell. Now, besides this, it can also be called a stable octet electronic configuration. Now, octet because it has 8 electrons, which makes the outer electron shell fully filled. Okay. However, if it's too difficult for you at this point in time, do recognize that the whole idea is to achieve a fully filled outermost electron shell. So long as you can tell me this, I think you have gotten the concept. But this fully filled outer electron shell can also be known as other terms. All right. Now let's take this down. This is how sodium forms its ion. Okay, by losing one valence electron. Okay. Now for those in the Zoom meeting, once you have finished copying this down, can you please give me a thumbs up so that you're done? Maybe I zoom out a little bit so you can see that you're supposed to have copied down a number of things. Now for the N levels, both the drawing of the electronic structure and the explaining in words will be tested. So you need to be familiar with this, actually very familiar with this. Okay. Now that was the sodium atom. Okay, sodium is a typical example of a metal, right? Metals are found on the left-hand side of the periodic table. Sodium is a metal. Sodium loses one valence electron to form a positive ion. And this is typical of metals. Metals generally will lose electrons. And metals generally will form positive ions. Okay, so the same can be said for potassium. Potassium is a metal, so potassium will also lose one valence electron. All right, can? Now, do all metals lose one valence electron? Obviously, the answer is no. If you go to group 2, magnesium is in group 2. Magnesium has 12 electrons. Okay, this is from the periodic table. You look for magnesium, the proton number is 12. Therefore, the electrons also 12. So that's 282, you know. So now immediately you realize, okay, magnesium is not going to just lose one valence electron because magnesium has 2 valence electrons. All right. So if you have 2 valence electrons, you must lose 2 valence electrons. Okay, so the idea always is it has to lose the number of valence electrons to achieve a fully filled outermost electron shell. Okay, now you realize that it has lost 2 valence electrons. So if it loses 2, clearly it's positive ion, but is it just 1 plus the charge? If you lose 2, the charge must be doubly positive, so 2 plus. So magnesium forms the Mg2 plus ion when it loses 2 valence electrons. All right. So you can even draw it out. The magnesium atom is 282. Okay, 282 is drawn like this. Magnesium ion is 28. Remember the square bracket it up and put the charge outside the square bracket. So the atom and the ion is not the same. All right. And you can also practice writing out the lines. All right. Magnesium atom has electronic configuration 282. Hence, it loses 2 valence electrons to form the Mg2 plus ion to achieve a fully filled outermost electron shell. Okay, but this hopefully gives you an idea that metals will lose valence electrons to form positive ions. Okay, so Mr. So is not going to write out the paragraph to describe how magnesium forms the ions. Practice it yourself. It's similar to sodium, just that for magnesium, it loses 2 valence electrons to form 2 plus ions. Okay. And so we can generalize. If it's group 1, it will lose 1 valence electron. So the ion is 1 plus charge. Group 2, lose 2 valence electrons, so 2 plus charge. Group 3, lose 3 valence electrons, 3 plus. So there are many examples of this. Sodium is in group 1, so Na plus. Magnesium, group 2, Mg2 plus. So we just saw these 2 examples. Okay, group 3, aluminium forms 3 plus. Okay, so these are rules. These are rules that will help you. Okay, now this is really important because later on, you will need to write equations and formula. So knowing the charges that will be formed by different elements based on their group will be very, very helpful. Okay, so that's for metals. Metals lose electrons, valence electrons, okay, to achieve a fully filled outermost electron shell. Okay, now we're going to move on to non-metals. So non-metals are found on the right-hand side of the periodic table. So today we are just going to see one simple one. We're just going to talk about oxygen. Oxygen is easier. Now the oxygen atom has 8 electrons. But don't be fooled, okay, by this. 8 doesn't mean that, oh, all 8 are in one shell, right? 8 electrons means the first shell contains 2, the second shell contains 6. This means that oxygen has 6 valence electrons. 6 is not a fully filled outermost electron shell. It has 6 valence electrons. It's not fully filled. So oxygen is in group 6. It has 6 valence electrons. It doesn't have a fully filled outermost electron shell. So what will oxygen atoms do? Will they just lose 6 valence electrons? Or is there an alternative? Of course, there is an alternative, right? The whole idea is I must achieve a fully filled outermost electron shell. So if that is the case, I just need to make it to 8 electrons. Currently, I have 6 electrons already in the outer shell. So how many more electrons do I need to gain such that it achieves 8 electrons? From 6 to 8, I will gain 2 valence electrons. All right, so it becomes 2, 8. So by gaining 2 valence electrons, it would have achieved a fully filled outer electron shell. And this is called the ion of oxygen. Clearly, it has gained electrons. Gain electrons, electrons are negative. So it's a negative ion. You gain 2 electrons, so it's the O2 minus ion. Now this is called the oxide ion. So for negative ions, their names change slightly. So oxygen atom becomes the oxide ion. Okay. Now you're also able to draw this out. Okay, 2, 6. This is 2, 6. The oxygen atom. Now we draw the ion. Now when you draw the negative ions, you must be careful. Why do I say you must be careful? Okay, sorry. I used the wrong symbols. We should have used dots for this. Can we use dots for this? So for oxygen, let's use dots to represent the electrons. Now for the negative ions, you must be more careful because the 2 electrons that are gained must be drawn using a different symbol. Okay, so can we please take note? The 2 electrons gained by a negative ion, okay, must be drawn using a different symbol. Okay, so this is how you draw the oxygen atom and the electronic structure of an oxide ion. Okay, oxygen atom, oxide ion. Now, so you realize this is another series of patterns, right? Your non-metals can be found in which group? They are found on the right-hand side. So they can be found in group 5. Group 5 will gain 3 electrons, so it's 3 minus. Group 6, like oxygen, gain 2 electrons, so it's 2 minus. Group 7, gain 1 electron, 1 minus. So this is the property, the summary, okay, of how non-metals can gain valence electrons to form ions of different charges, right? So for those in the Zoom meeting, once you have finished copying this down, just give me a thumbs up so I know you're done. Okay, so writing it out in words, so we have drawn it out, so now we also need to write it out. So the oxygen atom, so what we started with is the oxygen atom has electronic configuration of 2,6. Okay, so you started off as 2,6, so it gains 2 valence electrons to form O2 minus ion. So the oxide ion to achieve a fully filled outermost electron shell. Right? So that's how we write out in words. And with that, we have seen how metals form positive ions, non-metals form negative ions. All right, so that's a big step forward. So now, of course, it's okay. So what if it forms ions? Where do these electrons that oxygen gain come from? Right? So you saw that oxygen gained 2 valence electrons, but where did these 2 electrons come from? Well, it must have come from something that lost these electrons. So oxygen gains electrons, but these electrons must have come from a metal that lost these electrons, right? And that allows us to begin visualizing reactions. That's how oxygen will react with metals. Because metals will lose the electron, oxygen will gain the electron. So we can say that the metal transfers the electron to the non-metal, right? So now, what if Mr. So said, so now if I give you a compound that contains magnesium and oxygen, this is called magnesium oxide. Magnesium oxide is a compound formed by magnesium and oxygen, right? This is ionic compound because there's a metal and a non-metal. The metal is magnesium, the non-metal is oxygen. Magnesium, then you have oxygen. But this is ionic. So if it's ionic, I must consider their charge. How do I know their charges? I go to the periodic table, I look for magnesium. Magnesium is in group number 2. Right? Magnesium is in group number 2. Group 2, just now I learned, the pattern is group 2 lose 2 electrons, so 2 plus, so Mg2 plus. Oxygen, we just did it, right? Oxygen is group 6. So oxygen gains 2 valence electrons, 2 minus. Now, what's the purpose of writing out the charges? It is so that you know how many magnesium and how many oxide ions there will be in the formula. Okay, so quite clearly here, the 2 plus and the 2 minus, they are the same charge, right? So the charges balances out. And therefore, the final formula is just MgO. 1 magnesium ion, 1 oxide ion. So when it comes to drawing, it's easy. I have 1 magnesium, 1 oxide. Now this is ionic, so I need to think. Magnesium is 282. But to form 2 plus, it lost 2 valence electrons. So now it's 28 with a 2 plus charge. Okay? So you got to do this working in your head. But if you cannot do the thinking, the mental working in your head, you can write it out on a rough piece of paper. But in the answer blank, you should not have working. Okay, the question is always draw. Draw the dot and cross diagram to show the structure in magnesium oxide. So you must get to the Mg2 plus electronic structure immediately. How do you draw O2 minus? Just now we just did it, right? Now oxygen is 2,6. So 2,6 means it gained 2 electrons. So the electrons gain must be drawn in a different symbol. Different symbol. All right. And don't forget, must square bracket up and put the charge 2 minus outside. So this is magnesium oxide's dot and cross diagram. Okay. So this is MgO. So let's revise the steps. Whenever you're asked to draw the dot and cross diagram for an ionic compound, firstly, you know it's ionic because it's metal and non-metal, magnesium, oxygen. Okay. Next, once you know it's ionic, you must write out the charges. In this case, Mg2 plus or 2 minus. You must write out the charges first. Once you know the charge, then you know the formula. Because it's 2 plus and 2 minus, so just one magnesium and one oxide ion will do. It balances out. So it's MgO. Okay? So once you know it's MgO, then you can draw out the positive ion and the negative ion, Mg2 plus or 2 minus. Now, generally speaking, we will not be asking you very complicated atoms and ions. So please ensure you know the typical ones like Na plus, Mg2 plus, O2 minus, Cl minus. These are the typical ions that we will test. So this is magnesium oxide. Okay, it's an ionic compound and the dot and cross diagram is shown below. Okay. Now, so what if I wanted to draw something different? Also another ionic compound, but this time around is sodium oxide. Instead of magnesium oxide, I want to draw sodium oxide. How? We will use the same steps. The first step is you need to know it's ionic. How do you know it's ionic? You know it's ionic when you have a metal and a non-metal. So the metal is sodium, Na. That's a metal. Oxide comes from oxygen, so that's a non-metal. So immediately you know it's ionic. It's an ionic compound because there's a metal and a non-metal. Next, once you know it's ionic, you need to write out the charges on the ions. This is where your knowledge of the charges will come in. Sodium is in group number 1. So sodium being in group 1 has 1 valence electron. So it will lose 1 electron to form Na plus. So the charge on the sodium ion is Na plus. The charge is 1 plus. Okay, then once you have established sodium is Na plus, then you go to oxide, that's 2 minus. So immediately you realize, okay, this is not the same as magnesium oxide because the charges are not balanced. Sodium is only 1 plus, whereas oxide is doubly negative, 2 minus. Therefore, the formula cannot be this. This is the wrong formula. NaO is wrong. 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 So please don't jump to conclusions. There must always be one of each ion. Doesn't work that way. The way it works is for the positive and negative charge to balance out. For the positive and negative to balance out, in the case of sodium oxide, we know that oxide is double negative. So sodium, you will need 2 times the amount of sodium in order to balance out the double negative charge. Okay, so it's Na2O. So what this means is there are 2 NAs, there are 2 Na plus and 1 oxide ion. Importantly, please put the ion that is in a smaller amounts in the center. So oxide is in the center because only 1 oxide ion, but you got 2 sodium ions. Okay, next, we know that sodium is Na plus. Okay, so you can immediately draw out like that. You know that oxide is 2 minus. Okay, now you need to fill in the electrons carefully. Sodium is 281, so it loses 1 electron in the outer shell, becomes 28. Okay. So this is sodium ion. Then you have the oxide ion is 26. Okay, it's 26, but it gains 2. The 2 electrons gained must be drawn in a different symbol. Oops. Sorry. Okay, so this is how you draw the dot and cross diagram for sodium oxide. Okay, so please ensure that you get the correct ratio of the ions before you start drawing. The last thing you want is to draw the wrong number of ions. Okay. So once you have finished copying, give me a thumbs up so that I can move on as well. We're going to move on to just one last thing. Now, just to also take note, drawing of dot and cross diagrams like this is 2 marks. That's quite a lot. 2 marks is 4% of your grade, for chemistry. So really, right, chemistry, the 2 marks just to draw a dot and cross diagram, although yes, there's quite a number of steps to think of, it's not very difficult. So we need to be able to do this well. Right? Please don't jump to conclusions. I notice some of you will jump to conclusions that, oh, there's only 1 sodium, 1 oxygen. May not be, right? As in this case, you saw it's Na2O. You need 2 sodium ions to balance out the charge on 1 oxide ion. Now, so what makes the ions stay together? Clearly, there's a force of attraction that attracts the ions together, right? So what is this force of attraction called? Now, there's a force of attraction which is called the strong electrostatic force of attraction. And this is between the oppositely charged ions. So what is electrostatic? Now, this word electrostatic means positive attracts negative. All right. Electrostatic just means positive ions attracting negative ions. And this is an electrostatic force of attraction. All right. Can? Now let's take this down. Okay. So now that we know it's a strong electrostatic force of attraction between oppositely charged ions, we can begin to explain why ionic compounds have high melting points. So ionic compounds like magnesium oxide, sodium chloride, they have high melting and boiling points. Why? Because when you want to melt something, you must overcome the forces of attraction. You need to separate, increase the spacing between the ions. So ionic compounds, they all have very high melting and boiling points because there are strong electrostatic forces of attraction between the oppositely charged ions. Oppositely charged means positive and negative ions, right? So you must be able to say and link the concept of melting and boiling to overcoming forces of attraction. Okay, and these forces of attraction are called strong electrostatic forces of attraction between ions. So because these are strong forces, you need a lot of heat energy to overcome. Okay, a lot of heat energy is needed to overcome the strong electrostatic forces of attraction between the ions. Okay, so if we need a lot of heat, that means you need to heat it to a very high temperature before it can melt. Okay? Can? So this explains to you why ionic compounds have high melting and boiling points. Now, how high is high? Something above 500 degrees Celsius is considered high. So typically, right, ionic compounds will melt at temperatures above 500 degrees Celsius. So for example, magnesium oxide, just now you drew magnesium oxide melts at 2000 degrees Celsius. It's very high. Okay. So can we just check that you have this concept? Okay, when you melt something, the whole idea is to separate and increase the spacing between the ions. So to do this, you must overcome the forces of attraction, which are called strong electrostatic forces of attraction between the oppositely charged ions. Okay? So you must be able to explain why the ionic compounds have high melting and boiling points. And that is in terms of the forces of attraction. Okay? So that brings us to the end of the lesson today. Thank you. I hope to see you next time. Let me stop the recording first. Thank you.